In this class, let us discuss about mechanism of evolution. So, in previous concept itself, we were discussed about different types of the proofs for evolution, evidences for the evolution and adaptive radiation that and all we were discussed. Natural selection, matching of descent, all those things we were discussed. Now, in this session, let us discuss about mechanism of evolution. Here, they were mentioned two scientists' names. One is Charles Darwin, and another one is Hugo de Vries. These are the two scientists' names who are mentioned with respect to mechanism of evolution. Now, in this concept, what they were mentioned means according to the Charles Darwin, according to the father of evolution, evolution is a slow, directional process. Means what? In these organisms, mutations will be takes place very slowly. Mutations will be takes place very slowly. Mutation in the sense what? Mutation in the sense changes in a DNA sequence. That is nothing but called what? That is nothing but called mutations. So here, according to Charles Darwin, the mutations were slow and directional. Means what? When goes on, because of those mutations, we can expect, we can predict the changes which were taking place in speciation. But according to the Hugo de Vries, single step large mutations. Single step large mutations means what? For the formation of for the origin of a new species, the mutations will be takes place within a single step, within one generation. According to his concept, within one generation the changes are going to be happens, and it is directional less. So, in this concept, we cannot predict what are the changes are going to be happens. We don't know the sequence. We don't know the what in which type the mutations are going to be happens. So here in this condition, we cannot be able to predict the changes which were taking place in the evolution during speciation. This single step large mutation is nothing but called starvation. Single step large mutation is called what? Starvation. This was proposed by Hugo de Vries, but it was not accepting process. Why? Because the changes which were not to take place within a single generation. The miracles were not happens in a single generation itself. It is a continuous process. It will takes over million years to get a new species existing organism. According to the biogenesis theory, one organism is going to be responsible for the formation of, for the origin of new species according to the environmental factors. So this was not accepting, and throughout the world we are accepting that the mutations, the mechanism of evolution is slow and directional process. That was announced by, that was proposed by Charles Darwin, is nothing but father of evolution. And next, let us discuss one more concept, is nothing but Hardy-Weinberg principle. Hardy-Weinberg principle. Hardy is a mathematician and Weinberg is a physicist. Here, till now, whatever the theories were proposed, whatever theories were proposed belongs to evolution. With respect to origin of new species by biologists or naturalists. However, by several experiments, by several observations, after so many discussions, these people were proposed that the origin of new species is mutations. The reasons for new species, origin of new species: mutations, natural selection, gene migration, genetic drift, etc. So, for the origin of new species is, the reasons for origin of new species is mutations, natural selection, gene migration, genetic drift, adaptive radiation, and etc. So many aspects over there. Okay, let it. So, you knew that what is mutation, what is natural selection, adaptive radiation. But now you knew the new words for use: gene migration, genetic drift. Gene migration is nothing but the organisms can move to a new geographical area. The gene is automatically going to be migrated, and the organism is adapt to that geographical area. Then the new species is going to be arose. Then genetic drift means what? Because of the natural calamities, the smallest population is going to be vanished. Smallest population gets affected. So all these things were the reasons for origin of new species according to the biologists. These many works were done by the biologists. Now the mathematics and physics people was keep their finger in this evolution. physicists was kept their finger in evolution. What they were kept, what they were proposed, means nothing is there. Here they were proposing that the Hellenic frequency, the Hellenic frequency in a given population is always constant, say, and equal to 1 from generations to generation. How it is possible? Means, for example, how it was always equal to 1. The Hellenic frequencies, how the always equal to 1. Means, for example, you are well known about monohydrons. Let us take, for your confirmation purpose, let us take pairs. Homozygous male, homozygous female. Let us check Hellenic frequency. How many capital were there? 2. How many small t were there? 2. Is the Hellenic frequency is 1 or not? Pairs. Let us take next generations. What are the gametes are going to produce by these organisms? Capital T, small t, combined together forms capital T, small t, hybrid F1 generation. Parents generation, next generation. How many capital T were there? How many small t were there? Next, go for self-pollination among F1 generation. Among F1 generation. Parents, capital T, small t, capital T, small t, gametes, possibility for gametes what? Male, female. What are the gametes? Capital T, small t, capital T, small t, combination. Capital T, capital T, capital T, small t, capital T, small t, small t, small t. Now, here, let us take. How many capital T were there? 1, 2, 3, 4. How many small t were there? 1, 2, 3, 4. See, we were gone with three generations. One is the parent generation, children, grandchildren. So if you observe, the allelic frequency is always 1. Is it possible? According to the biologists, it was not at all possible. According to the biologists, it was not at all possible. The reason is one, the organisms are always forms undergoes the mutations or natural selection or migration or genetic drift or adaptive radiation. All those things we were discussed in previous sessions itself. We knew the meaning of all those things. So, in a given population, anything is going to be happens. Then how it will become is equal to 1. Then these people, the physics and mathematics people in the sense, you knew that they will be apply some conditions. They will apply some conditions. What are the conditions? According to this Hardy and Weber principle, if nothing is happened in the sense, nothing is happened in the sense, nothing in the sense what? There is no changes at all in the environment regarding biotic and abiotic factors. Then the allelic frequency in a given population is always equal to 1. But how it is possible without having any changes in the evolution itself? It was not. And this they were expressed with the help of binomial expansion. Binomial expansion. What is that binomial expansion? That is P plus Q whole square equal to P square plus QPQ plus Q square equal to 1. Here, what they were going to represent? Here, P can represent dominant character. Dominant character in a given population. Dominant allele. Q gives recessive allele in a given population. P square homozygous dominant allelic frequency in a given population. Q square homozygous recessive allelic frequency in a given population. PQ represents that heterozygous allelic frequency in a given population. These are the things are going to be represented by this equation. So always homozygous dominant, homozygous recessive and heterozygous. The allelic frequency in a given population is always equal to 1. When whatever the conditions were given by the biologists which were responsible for the formation of the new species, if all those things were not happening in the sense, then the allelic frequency in a given population is equal to 1. But it's highly impossible. But it's with respect to the comparative orientation, it's very, very important. One question will come to you regarding this concept in NEET examination itself. And next, let us discuss about one more concept is founder effects. Nothing is there. So if to any geographical area, if to any geographical area an organism was with specific character, whatever, an organism with a specific character. After several generations, if you observe, the entire population is possessed, entire population is possessed with the same characteristic feature. That's nothing but called founder effect. Means what? According to this concept, whatever the organism was entered into any new geographical area, what are the characteristic features were carried by them. So in that area, only all the population, the entire population is continues the same characteristic feature only. Other than that, there is no possibility to get a new characteristic feature. Is nothing but called founder effects. Clear? And we knew that the reasons for speciation is speciation is we knew that speciation or the reasons for speciation is either mutations, recombination, gene migration, genetic drift, etc. So all these things will be reasons for the origin of new species. Here, whenever the natural selection in a given population exhibit by three types of the graphs, they were stabilizing, next directional, next disruptive. These are the three types of the changes can be exhibited by a given population. What are those? Stabilizing, directional, and disruptive. So according to that, they have some graphs. Let us examine all those things. For example, in a given population, the given population is present like that. Let us imagine. So, in a stabilizing condition, how it will be present? It will be present like point. The peak is pointed. Means what? In stabilizing condition, the mean character value will becomes, the acquired mean character value becomes peak. That is about stabilizing. Means in a given population, whatever the characteristic feature, whatever the phenotypic characteristic feature is present more, that will be present in a peak condition. That is nothing but called stabilizing. That is nothing but called stabilizing. Then, if you take a direction, how it is present? Here, it was present little bit blunt. Little bit blunt it is present. It was not present in a peak. Means how it is present? Here peak shifts in one direction. Peak shifts in one direction. Here what will be happen? More individual acquire more individuals acquire other than mean character value. Other than main character value. That is directional. Means here we can expect the natural selection. What are the changes are going to be happening. Here, other than phenotypic characteristic feature which can be exhibited by the most in a given population. Other than that, a new characteristic feature is going to be appears. Here, disruptive. Disruptive in the sense what? We will be get two peaks. Two peaks. Means what? In this condition, two different types of this species. Not different types. The organisms with two peripheral characters. Two peripheral characters. Means what? Those two organisms were not appears like their ancestors. Species was same, but the new characteristic features are going to be exhibited. That is nothing but called disruptive or diversifying natural selection. All those things are going to be happens for the speciation. During the speciation, during the origin of new organisms, all these things are going to be happens. So this is the different types of diagrammatic representation of natural selection. Right? With this, we will completed that different types of mechanism of evolution, hardly principles of fauna effect and basis for speciation. With this, we have completed one of the concepts with respect to the evolution. We will be continuing with the next time.